First is called as frequency mixer or frequency converter. This is alternatively also named as heterodyning. And here what happens is if you have some signal, then the signal is of course modulated. Then after passing through this process, changes the carrier frequency of modulated signal from omega c to omega I. Means if you have modulated some signal and there is a carrier frequency, and if you want to change the carrier frequency of that and shift the spectrum entirely to a different region of frequency, then this thing can be applied. This is called as frequency mixing and frequency converter, or you can also call it as heterodyning. And mind you, in this case, we do not change the frequency of the sidebands. Means sidebands will relatively remain at the same position with respect to the carrier. And the second method is frequency multiplier, where the carrier frequency as well as the frequency deviation are multiplied. Means carrier frequency is of course shifted to the frequency that we desire, and the sidebands are also shifted relative to the carrier frequency, right? So these two concepts we will be first covering, and then we will look at the NBFM generator, that is narrowband frequency modulation, how it is generated by using a DSB SC, that is double sideband suppressed carrier modulator. And this is an amplitude modulation schemes modulator. So we will see it in great details, and then we will know by using this frequency mixer and frequency multiplier, we will be able to generate WBFM from this NBFM. And the aim of today's video is we want to understand this complete diagram. Here you see that you have got this NBFM generator in blue, and rest of the arrangement is made for shifting your signal to the appropriate frequency in frequency modulation, that is FM, which is usually 91.2 megahertz and around it. If you listen to FM radio, then you know that the channels are around this range only, right? And the frequency deviation that we need is this much. So we will understand this diagram in great detail. It is not a block diagram that you just remember and write down in examination and forget. This will be very helpful for generating practical devices that transmit FM signal. And by studying this in great detail, you will be able to design your FM modulator by yourself by just purchasing basic components which are there in laboratory. And after it we will go for coding. So let us begin with frequency mixer or frequency converter. As I have already stated that frequency mixer or frequency converter, it will change the carrier frequency of modulated signal from omega c to omega I, right? So it will not disturb the frequency of the sideband relative to the carrier. Means the spectrum of the modulated signal will be transferred to other frequency, right? That's what is going to happen in frequency mixer. Now let us understand it. Let us develop the theory of this frequency mixer or converter by using the DSB SC modulation scheme, right? So it is also applicable to all other kinds of modulation also, but for the purposes of development of theory, as it is given in various textbooks, let us take a modulated signal which is mt into cos omega ct. So this is double sideband suppressed carrier modulation scheme, and to be able to shift this to frequency omega I in place of this omega c, we need to have mt into cos of omega it. Omega I is the frequency at which we want to shift it. So this complete thing is done for that purpose. So to be able to do that, we multiply this by another cosine signal such that its frequency is omega mix. And what is this omega mix? Omega mix has to be omega c, which is the frequency of original carrier, plus minus omega I. This I frequency, omega I frequency, is the frequency which we desire to have in the carrier signal. After this multiplication and some simplification, if you solve your equation, you will get this final answer, right? Mt into cos omega it plus cos 2 omega c plus minus omega I into t. And if you apply a band pass filter, which is centered at omega I, then you will be receiving mt into cos omega it. So that is how you have shifted mt cos omega ct from carrier frequency omega c to omega I. And this omega mix could be anything, omega c plus minus omega I. If it is plus, then we call it as up conversion, or otherwise it is called as down conversion. So it's a very simple process. You have a modulated signal, you multiply it with the frequency and the sum of the carrier frequency at which you want to shift it, like omega mix, and you apply appropriate band pass filters, right? So this is how the frequency of only carrier is shifted. Nothing happens to this message signal. Message signal remains as is, means for demodulation purposes, there is no change for message signal.